Hello, I want to talk about data validation. There's some times that values that are not expected are seen in our table, and that has to relate to it. So we need to validate our data. For example, here, see age. Age is containing -5 here, negative value. So we need to validate it to make sure that it's consistent. So it only has 28, Aduke has 24, that one has it should be an error somewhere. So we need to just do something about it. That is validation and the consistency check. Now, let me run this for us to see what I'm talking about. You can see DF is this. You know that the original, you want to see the original value. You came from feed, you have collected data, and you are seeing -5. You know something is wrong. So let me run this for us to see the original table. See, the original data frame is this. You can use table or whatever. Here, see, we have 4 of them, and here is having -5. Something has to be done with it. So we have to check for the negative each. How do we do that? Now, see, the the table itself is this F, and the each is what is having problem. Now, we want to isolate the age. Now, the lambda you see here are the values here. Lambda is referring to the values here. Now, we are now putting a condition. Now, if x here, there's any of this, if x here, 28 or anyone want to use, we now put a conditional statement. If x is greater or equal to 0, let it remain. Else means if it's not following this condition, put this there. Declare it as missing value. Now what it means. So if this hold, the same thing we use in our here. If this one hold, let it remain. Else, put this there. It's very simple. So, and the new table you are going to form, you're going to put on it data frame after validation check. We can't allow this to go into our analysis. -5 will not, it will run, no, it will run. Quite agree, but it will affect our result. So let me run this. You can see, compare this with this. So Adamu, instead of having -5, because at the time we work and people we are working for would like to see what we are, the original value. So seeing -5 under this, just like seeing 3 under gender. In this our country, we don't have more than 2 gender. We have male or female. Generally, you are a man or a woman, male or female. So every time you are now seeing 3, because 1 can go for male, 2 can go for female. When you see 3 anywhere, you know that it's an error. Now, I want to quickly go to exploratory data analysis. That is where we talk about. This is one of the simplest and is the most expected. No matter how complex your analysis is, by the time you have not show us the descriptive statistics, some call it summary statistics, just the same thing. The mean, the median, the mode, variance, standard deviation, range, some other ones, they are many there. You have not done anything because you have to describe your data. Some people even go to showing us the minimum, the maximum, the first quarter, second quarter, like that. Very, very important because it describes our data. That's why we call it descriptive statistics. Still maintaining the data I'm using for this Wale, Ola, Ade, Gloria. I just change their name. And I introduce another column called score. So now I can separate this from all of them, but they work. Okay, let me just separate this, create another on top. Just type A and this here. So I'm able to run this separately. So let me run this and see the table has come out. That data frame. Let's call it data frame. So if I don't want data frame, I can change it to data table. So now the mean now, maybe I should also separate them if I don't want to. So you still have our results since we have the the title of each of the table here. So now the mean age. Now, for example, we want to calculate the mean age. We have to that we can calculate their mean. Under some statistics here, their age, their scores. So you can see the mean now. I've said it. Just isolate the column, and don't forget the name of the general. The family table is this. The family name of the table is DF. So bringing out any of this, you have to write in this kind of bracket, and the name of the real function, the command working here is the mean. Unless you want to derive another one yourself, which is permitted. When you write a function, it will work. But default is the mean. If you are looking for the mean, just write the mean here. Then you don't put anything inside here. You don't put anything inside. If it's R now, you have to put the name of the variable inside. But for Python, you just allow it like this. Dot mean. This one, we are run this one alone. It will give me the mean. Now, for score, we have age here. We have age, we have score. So that of score, just isolate it. Put the name here must not change. Don't go and write. We have capital. This one is starting with uppercase, capital letter of the name of the variable. You don't go and put small letter A here. It will not work. So the same thing with this. Now, their result will come out here. Now, the idea of using, I've said it, the idea of using the name here is to be able to distinguish the name of the variable by the time the result is out. So here you can see what we are putting here to represent it. Same thing goes for the median, same thing goes for the mode. Very easy, very easy. And same thing goes for variance, and same thing goes for standard deviation. For standard variance is VAR, for variance is VAR, for standard deviation is STD. Can run all of this together will give us our results. Let me run and see. So the mean age is 24.7, mean score is this, median age is this, median score is this for each of the variable we have in the EF. So the variance is this. You see the long, that's one thing with Python, give us long decimal place, just like I said. R also does that, but SPSS will not give you this long one. So to summarize it, we just give us like 2 decimal places. So that's that. If you want to visualize this, you can visualize also using this. Now before I leave this place, you can use, for all these things we have done, you can use just ordinary describe. Describe, we also do it. If I want to use describe, I can say df dot maybe age now. Age. Okay. This one is showing our first video. Okay. Age. Isolating this. So when you use this and put describe there, it will also work. Then here we can run each of this. When you run this, it will it will you can see each of them, the line plot, the bar plot, the bar chart, histogram. So bar chart is different from histogram. In the first video, I've shown all of this. So, and this will give us what we want. Let me run it. Now we can do this one after the other. We can cut this. What is doing this is the the library doing this is matplot. You must have imported it, and you must have before even importing it, you must have installed it using the command prompt. And we are going to have all of this. This is line plot. This is bar chart. There's difference between bar chart and histogram. In histogram, they are joined. In bar chart, they are separated. The bars are separated. Thanks for listening.